Hey everybody, I decided to use OBS and a bad microphone from my webcam to record my SolidWorks session. This is a variation of a fire truck, and for those of you who don't know about a fire truck, the primary features are this. There's an arm that comes out of the back of the base plate. I call it the fire arm, and it goes into a hole that's in the back of the hanger to create a supported hanger. What this does is it provides a very precise axis of rotation, and where normally this could be a problem engineering wise, I solve one of the problems with the kingpin and bushing setup by doing the following. Normally with this arm supporting the hanger like this, if I were to just tighten up this lock nut here, the washer would push the bushing down, and this bushing would basically crush the bushing seat because this arm is supporting the hanger and it can't really move downward or hinge, from the pivot like a normal RKP reverse kingpin truck. So in order to solve that, what I did is I put what I call a fire tube. It's a sleeve that goes around the kingpin and prevents the head of the kingpin from coming up against that face there, which is where kingpin head normally ends up when you're putting together a normal RKP. So why would I do that? I do that because that tube has the effect of pushing up on the underside of this bottom washer. Now, why would it do that? Well, it would do that because I'm tightening this one down and it's pushing the material down in such a way where it ends up um, pulling this one up. So you can see there's this kind of an accordion effect. But if you didn't do that, it would crush the bushing seat. And this bottom bushing, had there been two, in this case I'm only using one bushing and no bushing seat. I'll get into that in a little bit. But this bottom bushing wouldn't get any pressure on it, wouldn't get compressed when you tightened it up. And so it would be kind of a half good, half bad truck with some engineering flaws. So the floating kingpin system that I use is a part of this new truck. I'm calling this either the snap or the RTC, that's short for return to center, because this is going to be a very surfy, very snappy feeling truck because of what I've done. And the major difference in this is this bushing. This is one single bushing and it goes through the middle of the hanger. The hanger does not have a bushing seat on it. Well, how the hell is that supposed to work? Well, it's working because in lieu of a bushing seat, I have these rods that go through the bushing on each side of the kingpin. So when I turn this, it's actually these rods that are rotating up and back through a single bushing rather than a bushing seat, which is a plate-like feature of the hanger, teetering back and forth between two bushings that sandwich at top and bottom. So why would you want to do this? You want to do this because just pushing down on bushings it gives you stability. It gives you the ability to turn a truck and to have a kind of a normal feel. But if you have a rod here, when this is going down, the rod is pushing on the bottom part of the bushing, but more importantly, it's stretching the top part of this bushing where I'm showing you right here. So it's this stretching here that wants to give this truck a very snappy feeling and a return to center. Because, look at a wrist rocket or something where you're actually, or just stretching a rubber band that really wants to return back to its normal shape. Where if you just put your fist on a pillow and let go, even with memory foam, it kind of just comes back eventually, but it's slow and it doesn't have anywhere near the same kind of an effect. So a couple things here. One is that I've made one before, and so I know I'm in the right ballpark. But part of what I'm going to be doing here, let me kind of center this, is before I even try different bushing durometers, I'm going to make this different in that with different configurations, and that those rods can either be closer together and further apart. The idea being the further apart that they are, the greater the distance that they have to travel, and the harder or the more resistance there will be to lean steering when they're wider. Also, I can make the bushing thicker. In this case, I'm going from 5/8 to 3/4 of an inch, and there the rods are close together Here's a version where the rods are further apart. So going into the prototype phase, I want to try 4 different dimensions before I even get into the various different durometers or the characteristics of the urethane to make this thing work. So the other issue is somebody mentioned, oh, I'd like to see that in higher base plate angles. Not a problem. Here I've got a 50-degree base plate angle greater than the 45, and I can ultimately do whatever I want there. Here is an example of a 30-degree base plate, very different than the 50 that I just showed you. This would be more like a back truck, where the steering is going to be very flat, still very snappy and very responsive, but nonetheless, it's not going to steer it anywhere near the same angle as the 50 or the 45. So yeah, so these rods come in the backside and go through the hanger screwed in. There's various ways of doing that. I have gone to a urethane bushing. Urethane, plastic, nylon, anything but the bearing bronze that I'd used in the past. So it's a lot smoother ride than past Fyre trucks. And there's quite a bit of rake on this where the, and that's the distance that the axle is from the axis of rotation. So these things want to dive into a turn to begin with, but then that bushing setup is really going to want to allow you to snap that back. So speaking of the bushings, I'm going to show you a bushing mold setup here, and the bushing mold is going to basically be a cavity that I've made out of aluminum. There's the deeper cavity, and here is the shallow cavity. Rods are going to be put into those cavities to make the molds, and ultimately they're going to make some different bushings, either too thick bushings or too narrow bushings. May not be obvious, but the holes on the side here are wider apart than the holes on this side. So basically, by the time I get 2 of these bushing molds together, I'll have the 4 different configurations. Deep and wide, deep and narrow, shallow and wide, shallow and narrow. These things will ultimately press together and urethane will be poured in. And then afterwards, I have to take these things that kind of look like kingpins out and slide them out. Otherwise, there's no way to evacuate the bushing from the mold without cutting it, which would be pretty horrible. And then for people who are maybe interested in seeing another aspect of this, it'll be in, I gotta find where I put that. This is in the actual making of the bushing molds. So anyway, I'm going to get past some of these dialog boxes. This ultimately would be one of the first operations that I do on my CNC mill. This is a representation of the tombstone, which is the 4th axis rotary indexer that I have. This aluminum clamps up the piece here. And what I can show you, which will be, I think, kind of interesting to some people, is how I'm going to actually, cut this stuff. So I will begin this operation by facing, going around the sides and making some cuts to the front and back of the mold. And then I'm going to start a spiral morph down with a 3/4 inch end mill and do some of the heavy lifting, hogging out most of that. I'll go back in and do some finish passes and what's called rest machining, using a smaller tool to get into the corner. Some people will notice the red there, and yeah, my flutes and that tool aren't long enough, so I'm going to have to get a slightly longer tool to go that deep with something there. But in any event, by the time this is all done, I will have drilled the holes in the sides of the molds, put the rod holes down in there, and I'm going to go faster. But anyway, when that's all done, I'll have myself a couple different bushing molds. This is going to be like the thick one. I would do essentially the same thing a second time to make the thin ones. So get those filled with some nice urethane, go back here, make a couple different base plates, and yeah, that's going to be the snap truck. And I guarantee you, anybody who's ever done slalom or long distance pumping or heavy carving is going to appreciate the virtues of a Fyre truck with a single bushing that actually stretches and compresses. And lastly, I just want to say that other torsion trucks out there never have had a way of tightening up the truck. The only way to change the way that they steer has been by taking out the entire bushing and putting in one with a different durometer. So this one is the first one to really incorporate different bushing durometers, perhaps even different bushing size and rod placement, and then also the ability to tighten this up and loosen this up, because as this lock nut and washer goes down and that one come up, it will absolutely have an effect on the way in which this turns. It's basically just like what you already know, which is how to tighten up a truck. And get on your board and check it out. So that's all for now. I'm sure there'll be some more questions, but that probably answers more than I was willing to do by just typing stuff in on Facebook.